So an asymptote of a function describes what the graph is doing at extreme values of x, when x gets really, really, really big or really, 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 really small, like negative big. So what we want to do is, if you've done calculus, you recognize, the idea of a limit. When x gets gigantic, what's the limit of this function doing? And in Algebra 2 and in pre-calc, when you first learn it, they kind of toy around with that idea, but they don't actually say that you're doing a limit. But you are. You're doing a limit as x goes to infinity. So regardless of how we figure it, if we use the term limit or not, when x gets really big, we want to figure out what's happening. So if I rewrite this as, if I just divide both pieces as x minus 1 over x squared, this is a little bit easier to look at. Because when x gets really, really, really big here, 1 divided by a ginormous number goes to 0, right? If you're taking one pizza, dividing it among an infinite number of friends, you don't get that much pizza. So that goes to nothing, and so your function just becomes x when x is huge. And when x is huge, this goes, and so your function basically becomes this line, y equals x, for large values of x. So the equation of your slant asymptote is y equals x. So now I did this by breaking it up like that. It was pretty easy to do because this was just a monomial on the bottom. What you're taught in Algebra 2 and pre-calc is to just do a long division if necessary. So if you wanted to, you could take x cubed minus 1 and divide that by x squared. And they say just take the number up here and ditch the remainder because the remainder just doesn't matter. So if you did the long division, I'll add some placeholders, 0x squared plus 0x minus 1. Let's see, x squared goes into x cubed x times, so I'll put the x up here, and I'll have x cubed, and then I'll subtract. So x cubed minus x cubed goes away like we planned. There's nothing here. We're just left with the minus 1, and that's our remainder. We can't do any more. Pretty boring long division. It was much nicer to do it that way. But I remember when I took the class, I'm like, if the top is bigger than the bottom, I will do a long division, and this will be my slant asymptote there. And I just ditched that remainder. Makes a whole lot more sense to me now that I know calculus, and that's why we're doing it. That basically when you do this, you're figuring out that y equals x, what am I doing? Yeah, that this function, right, x cubed minus 1 divided by x squared equals x with a remainder of negative 1 over x squared. And when x gets big, this goes away, the remainder didn't matter, that's your asymptote. Ta-da! And then again, the calculus, the limit as x goes to infinity. By the same exact methods of doing it, it'll end up going to infinity, but it'll approach this line y equals x because of that. Okay. If you were to graph it, what it looks like when it's graphed is, so your function will approach the line y equals x. So you'll have the line y equals x with the y-intercept of 0 and a slope of 1. So you have this slant asymptote versus a horizontal asymptote because it's slanty. And a vertical asymptote looks like a 0, and that's, we've learned in other things. And if you plotted points, you get one of these graphs. So basically when you're looking at x's out here and you look at this graph, it's like, oh, you kind of just look like the line y equals x. If I were just looking at this isolated part of the graph, I would just be looking at, it would look like a line. Like if I zoomed in on it on my graphing calculator, it would just look like a line y equals